Okay, hi, this is Michael Ellis. Now, I've been doing some experimentation. So, so basically, actually, my whole house is grounded on a cloudbuster. So this is kind of like a half cloudbuster. I made a small one, just to use for experimentation in the house. And so so at first I tried wrapping some coils around the pipes to see if I could get anything, and that really didn't go anywhere. Um, but I am getting some signals coming out of the pipes themselves. So what I did was I took a microwave. I have this microwave transformer. It's pretty awesome. But it's a huge thing. So I'm not pretty sure exactly how all the coils work, but I think I got it hooked up right. So it's just using one coil, and as far as inductance goes, I'm getting one signal coming out of. I've just got it hooked up to one coil, input and output, and so as far as inductance goes, it's basically got a longitudinal signal coming out. So you can see the pumps, the pumping action, the rarefaction, and the compression. As the signal goes, it's got it's a longitudinal signal, so it has it's like so it's catching in the coil, causing the voltage to go up and down at the same time, and then to go back down towards zero. So yeah, that's how you can tell you've got a longitudinal signal. It just kind of like pumps like that. That's a longitudinal wave, like a Tesla called sound waves in the ether. If you look up longitudinal waves on Wikipedia, it'll show you how they kind of work like that. So yeah, these are longitudinal waves. You can tell that by how they look electrically. So what we've got is longitudinal waves, and they need to be transformed down to regular transverse waves. So yeah, so that's where we're at. So we need to do a like a coil around the. So actually, I guess I was in the right headspace. We do need to do a coil around the pipes themselves to get it down to a transverse wave. So there's actually some force, magnetic force, going up and down the pipes as far as longitudinal waves go. It's just like a Tesla coil. So to get energy out, we have to do a coil around the pipes, and that should get us energy as far as this goes. So I did these coils around here. Actually, I didn't have a very good experience with them because they didn't do a whole lot. But actually, I'm gonna try and hook them up to this transformer. So we'll see what happens. So I'm gonna hook that up there, and hopefully they won't be longitudinal anymore. Let's see. I've got a wire here. So I'll hook that up there. And I'm sorry, water's on it. Right, I don't know where the other one went. Right there. Yeah. See what that gets us. Not much. Oops, it's not hooked up. And we're flat. Okay, so now we've got an electrical signal. It's not doing a whole lot other than some hairy stuff. Let's zoom in a little bit. Now it's got a decent wave. You can tell it pinches off there. So yeah, it's oops, sorry. Messy basement. Looks like it's got a really long wave to it, but it's not really specific. So actually it's no longer in a longitudinal wave, as you can see. As you can see, it's no longer doing the pumping thing. It's just static mostly. So that's our longitudinal wave. Oh, Jesus. Look at how much negative the decibels are. So it's really low. Oh, maybe it's just because I'm messing with the frequency. No, doesn't have anything to do with that. Oh, that's kind of weird. Okay. Huh. Okay, interesting. So, so yeah, we've got longitudinal energy, or we've got transverse energy now. So the thing to do would be to try and do a capacitor battery or something to try and make sense of that. And try and get it going. Yeah. So yeah. So it's not looking at like much right now. So actually I'll check back in just a second. Okay, hi, this is Mike Lillis. Okay, we're resuming. So I got the coil from the Cloudbuster there. The blue coil hooked up to a diode and a battery, just to see if we could get anything. And no matter which way I hook it up, either direction of the coil with the diode, it is depressing the battery. So, and it's just in the millivolt range, so it's like a dead battery. So I'm thinking maybe that has something to do with the negative side. That's depressing the voltage. So actually I'm gonna get another diode. Actually, this will work. And put that on the negative one. So I don't know if, sorry, can't see this. So so I've got the negative one here, and I'm going to put it down. Actually, this is two diodes. Sorry. Actually, let's see here. So I'm gonna put a diode on there, and we'll see what happens. This is science in the making. See what happens to our battery. It's still depressing the battery. Isn't that weird? That is really weird. It's like the diodes aren't even there. That's science. That's really science. Well, when we make mistakes, we make discoveries, so. That is really weird. Ooh, this is kind of hot. Yeah, that's cold, warm. Oh, nice. Okay, this one feels warm. The bottom of a clockwise coil feels warm, which is the positive coil. This one feels the positive diode connection to the negative of the battery, and that side, the positive side feels warm, and the negative side feels cold. Oh, actually, that feels warm too. Oh, maybe because I was touching it. I don't know. Or I don't know. That's weird. That's weird. That was cool before. It feels warm too. That was weird. I don't know why it would be depressing the battery like that, even with the diodes on there. That makes absolutely no sense. Alright. So I guess more sciencing to do.